So in this video, we're going to look at using the trigonometric or the component method to mathematically derive what our resultant vector's magnitude and direction are going to be. We're then going to use the graphical method to draw out what we've actually found to be our answer in this example problem. So I'm going to want you to do this along with me, and I cannot stress enough how important it is to show all your work, because each of these sections is going to be worth marks. It's not enough for you to do this in your head and just write out an answer. I need to see your work. So the situation is this. Beatrice cycles for 10 meters per second in a direction of 160 degrees. She then cycles for 8 meters per second at a direction of 210 degrees. And finally, she's going to cycle at a velocity of 5 meters per second at a direction of 330 degrees. Now, the first thing you need to do, so what the question is actually going to be asking is, where is she in relation to her starting point? So when you have a question like this, and you have that sort of, where is she now? They're looking for the magnitude and the direction of the resultant vector. So we can't simply just say v1 plus v2 plus v3 and hope to get an answer. We've got to break these down using the x and y component of each of these vectors. Okay? Now, I'm going to write out the formula, and then I'm going to give you some time. I want you to pause the video after we've written out the formulas, and I want you to find your x and your y components for each of these vectors. Now, remember, when we're looking for the x component of any vector, the formula is such. Vx is going to be equal to the magnitude of the v times the cos of the angle, whereas the vy of that vector is going to be equal to the magnitude of the vector times the sine of the angle. So I'd like you to pause it now, and I want you to find the Vx, Vy for V1, V2, and V3. Okay? So if you look at the screen now, you'll notice that there's a lot of writing there. That is what I expect when you show me your work. Okay? Because here are your V1 and V2 values that we are now going to use. So we're going to basically come up with the x and the y magnitudes for the resultant vector. And we do that by summing all of these components. So I want you to add all of your x's together, and then I want you to add all of your y's together and see what you come up with. Now that we have our vrx and our vry, we can determine what the magnitude is of our vr, our resultant vector. And that's simply following this formula. So the magnitude of the resultant vector is going to be equal to the square root of the resultant x vector squared plus the resultant y vector squared. So take a few moments, work this out. Do not forget your units. You'll notice how I've been writing meters per second throughout the entire problem. This is worth marks, easy marks. Units are important. So if you look at the bottom of this slide, you'll see that I've worked out what my x and y components combine or are summed to give me my resultant vector's magnitude. So if a question only asks you for the magnitude of the resultant vector, you can stop here. But if it does ask you for a direction to go along with that magnitude, then that's where you're going to put in your inverse tan. Okay, so we're going to move on to that. Now, for the inverse tan, we're looking for that alpha angle. All right, and that alpha angle is going to help us determine the overall theta or direction of our resultant vector's magnitude. Okay, the formula is as follows. Alpha angle is going to be equal to the inverse tan of the absolute value of the VRY over the absolute value of the VRX. Now, where a lot of people make mistakes is that they swap these two. It's going to give you the wrong answer. You've got to be certain that you actually put your Y on top and your X on the bottom. Now, luckily this is absolute. We don't put any negatives here, only positive values, even if we've actually calculated both of our VRX and VRY to be negative numbers, negative 12 and negative 3.08. Those are going to become positive. So take a moment here. I'm going to pause it. Take a moment, work this out. You should get a decimal number here for your actual VRY over VRX. Take the inverse tan of it and it will give you a number, and that number will be your alpha angle. Now, be very certain that your calculator is in degrees, because I believe in mathematics right now you are doing something in radians, and that throws everything off. So take some time, get this done, and we'll come back. So if we look at working this out, we end up with an alpha angle of 14.4 degrees. Now, if I'm to stop here and look at this direction, I'm going to assume that my resultant vector should be in the first quadrant. That's what this number tells me, if I go with this number alone being my theta. In order to see if that's right or not, let's draw this out. So I'm going to